Hey, ladies and gentlemen. Today we're going to go over the thermal energy notes. Our goal here is to better understand how an object or a system can continually be absorbing or emitting thermal radiation. So, heat versus thermal energy. These two terms are commonly misused. Now, thermal energy is the total kinetic energy of the particles in an object. The more particles an object has, the more thermal energy that object will have. So an example is that the ocean is colder than a glass of water, but the ocean will have more thermal energy because it has more particles. Heat is energy that is being transferred between two objects. Now, heat can be transferred using three different methods: conduction, convection, and radiation. Now, how heat moves. Heat or energy will spontaneously spread from regions of high energy to regions of low energy. So it's trying to reach what we call an equilibrium or a balance. Now, to do this, heat will always move from areas of hotter areas to colder areas. So areas of high energy to areas of low energy. So always hot to cold. The three methods of heat transfer. The first one is conduction. Conduction requires two objects to be in direct contact for that heat to be transferred. So those two objects need to be touching. There's convection. Convection occurs in liquids and gases. The warmer substance will rise while the cooler substance will sink. This occurs because of the densities of the substances at different temperatures. This generally occurs when you're heating a liquid or a gas from below, and as a result, the heated gas will become less dense and rise. As it gets further away from the heat source, it'll cool off, become more dense, and then fall back down, giving you a very circular current. So this is called a convection current. Then there's radiation. Radiation is the transfer of energy by electromagnetic waves, such as light or microwaves. When radiant energy comes in contact with an object, it will either be absorbed or reflected by that object. Now, there are different ways of controlling this heat transfer. The first way is through reflective materials. Reflective materials can be used to trap heat inside of something or keep it out. This is like aluminum foil, or some jackets will have a reflective liner on the inside to help reflect your body heat back in. Um, Thermal conductors. These are generally made of metal. All right, thermal conductors can be used to transfer heat through conduction more easily. So, like a pan or a pot on a stove is metal, so that it will conduct that heat more readily. And then there's thermal insulators. This prevents the heat transfer through the process of conduction. Thermal insulators are generally used to keep food warm when it's cold outside, or cold when you want that food to stay cold. This would be like the handle on a pot or a pan on the stove. Generally, you don't want that to heat up, or like a spatula or something like that. You don't want that to heat up while you're using it. Thermal expansion. Thermal expansion refers to how kinetic energy of the particles that make up an object will begin to move more as they absorb more energy. Now, these particles are going to start to vibrate in place. The more kinetic energy they have, the more they're going to vibrate. The slight motion of the particles that make up that object will change the shape and size of that object, causing it to expand. Uh, What does temperature measure? Temperature is a measure of the average kinetic energy of the particles in a substance. We can measure temperature using three different units or scales. There's degrees Fahrenheit, degrees Celsius, and Kelvin. Here we can see the units for each of these three different systems of measurement. We have degrees Fahrenheit, degrees Celsius, and degrees Kelvin. Each one of these scales is based off of a different freezing and boiling point of water. Fahrenheit has 32 and 212 as our two main temperatures there, while Celsius is based around the freezing and boiling points of water, so it has water freezing at 0 degrees Celsius and boiling at 100 degrees Celsius, which is honestly a little bit easier to remember. Now, Kelvin is based off of the Celsius scale. However, it does not have a negative temperature. The lowest possible temperature is 0 Kelvin. That is the temperature where no particles have any motion at all, or known as absolute zero. Now, these three temperatures are all the same thing in either or in any of these columns. So Fahrenheit is mostly used in the United States, Celsius is used by the rest of the world, and Kelvin is used mostly for fields of science and for different calculations. Because it does not have negative values, it lends itself to mathematical equations a little bit more easily. Again, like I said, the coldest possible temperature in the known universe is 0 Kelvin. At this temperature, there is no kinetic energy at all. The coldest temperature we have achieved is right here. To do this, scientists had to cool off atoms using a laser to suspend them in place. Now, this, in case you're interested, is how we convert between different systems of measurement. Now, you can see to convert to Celsius, we've got our equation here, to Kelvin. To get from Kelvin to Celsius or Celsius to Kelvin, it's simply you just subtract or add 273. To get to Fahrenheit, it's a little bit more complicated. We aren't going to focus on conversions too much this year, so this is not something we're going to stress too badly at this point. Now, 3 states of matter. This should be reviewed from the very beginning of the year, so hopefully this seems a little familiar while we're talking about it. So solids have particles that don't move around, instead they're stuck in a definite structure. Liquids, their particles have the ability to move around a little bit more rapidly, but are still packed pretty close together. Liquids have a definite volume, but will change their shape to fit whatever container they're in. And then gases, their particles will move a little bit more freely and have plenty of space in between them. Gases will expand to fill whatever container they are in and can be compressed as a result. Now, when we change from one phase of matter to another, these are the different terms that we're going to need to know. Again, this should be reviewed from earlier this year. Melting is when we go from a solid to a liquid. Freezing is when we go from a liquid to a solid. Evaporation is when we go from a liquid to a gas. Condensation is gas to a liquid. Sublimation is when we go straight from a solid to a gas, skipping the liquid phase. And deposition is when we go straight from a gas to a solid, again skipping the liquid phase. And then phase change graphs. Now, guys, again, hopefully this is a review from earlier in the year. During a phase change, the temperature of a substance will remain the same. It does not change. So the substance will only heat up or cool off when it has completely changed into that new phase of energy, or phase of matter, excuse me. Once the entire substance has undergone a phase change, the temperature of the substance will then again increase. Flat sections of the graph indicate phase changes. So at point B and point D, we have phase changes occurring. A, C, and E on the graph are where we're in a solid, liquid, or gas state. That, ladies and gentlemen, concludes our notes for today. I hope you have a good one.